Okay. Can somebody's mic is on? Can they mute themselves? Okay. Let's start. Good evening to all. Very happy to have you join this session. This is the second in our series of sessions as part of the NASA Space Apps Challenge Panjim. Hope you can hear me. Yash or somebody can confirm. Umkar, can you please confirm? You can hear me?
We can hear you, Saish.
Yeah, perfect. Thanks for confirmation. So this is the second in the series of our sessions in which we are trying to provide some kind of exposure to the participants about what is expected. So this today's session will be on remote sensing and satellites. So this will give our audiences a brief idea about what do you mean by satellites and how remote sensing is carried out, what kind of data sets are there. So uh, this session will give you that information. We will have the next session coming Wednesday, which will be about the actual data points which the satellites will be giving. So immediately on Wednesday, we'll have the next session. So in today's session, we have with us Dr. Aparna Gandhi, who is a senior scientist at the National Institute of Oceanography. Uh, Her work entails that she works on day-to-day basis with satellite data. So one of the best person that you could get as resource persons today. We are very lucky to have her here. So she will speak about what are satellites and how satellites collect data and why basically do we need satellites to collect this kind of data. So her day-to-day job includes that she does this kind of work of collection of data and crunching that data to write papers. That's her kind of work. So I would like to now invite Dr. Aparna to present. So we will take questions maybe after the session. We are also recording this session. So we will share the recording once the session is over. We can take you can have the questions in the chat. That way we can all combine the questions to be answered later on. Okay, that's great. So Aparna, over to you. You can share the screen and present. I've given you the rights.
You all can see my screen?
No, you need to share we can see your screen, but we are seeing the desktop, I guess. Yes.
Okay.
This is better. Can you make this into a slideshow mode so that...
Yes. 1 second.
Yes, we will share the presentation also in the classroom. Thanks for pointing out, Saish. Yeah.
Yeah, now you all can see my screen, right?
Yeah, we can see your screen. Yes. Yes, this is perfect.
Yeah, just a second. I just wanted to know your background. Some of you are school students, some of you are working. So I just wanted to know what
So
kind
since
of
the mics are
audience I have.
muted, for all, I can respond to this question.
Recording in progress.
Okay, so most of the participants here, I assume are college students, very few being school students. But I would like to request you to start from very basic, assuming that we have very little knowledge about remote sensing. For those you already have some knowledge, it could be very basic for you, but please bear with us. This session is going to be very, very basic in terms of what satellites are and what remote sensing is.
Okay, but actually it would be nice to interact with the audience.
There is 46 people. Do you want me to? There could be a lot of questions. They could chat with you. Maybe you could.
Yeah, in
They can
case.
respond via chat. Yeah.
Okay. So today I'll be talking about what is remote sensing, why it is used, and how do the remote sensing is being done to a very basic level. So before going for sensing, uh, what is remote sensing? Let us look at what is sensing. What do you feel is sensing?
Recording in progress.
What do you feel is sensing? I'm looking at chats. Please respond. What do you feel is sensing? To detect something, to experience something? Yes. Now we have five sense organs, right? All of us know. One is sight, hearing, taste, touch, and then smell. We can from the far itself see what kind of match is going on, right? We can see who is playing, but we never come in physical contact with them. And when mama is cooking something in the kitchen, you already know what's cooking, right? When somebody knocks your door, you'll come to know, right? In these three senses, you don't have any physical contact with the object that is creating, right? And what about the remaining two? Can you look at some food item and say it is tasty? Yeah. Can you look at some food item and then say it is tasty or it is very soft or hard? No, yeah. So the remote sensing, the basic definition goes as you will know about the object, what it is to some extent without coming in a physical contact with that. Okay. And what is the most common remote sensor which you use? What's on the screen? It's camera, right? Most of us have used it. When you use a camera and take a pic, it's almost like a natural sensor is an eye, and its artificial replica is a camera, right? Without even looking at or touching it, you will come to know what is there, whether it's a plant or tree or land or ocean, right? These kind of cameras you can keep on any platform, whether it's a ground based or it can be an aerial based or it is a satellite or in the aeroplanes. Is there an echo?
You're sounding perfectly fine.
Yeah, fine. Okay. So there can be many platforms. So we will look at one platform that is satellite today. Before going to the satellites, we'll just understand the basics of remote sensing. When you see something, how do you see? What is required to see? Suppose an object is there. What is required to see? Yes, the light. It is one part of an electromagnetic radiation. Most of you have heard of that electromagnetic spectrum, right? So, light, in the sense, visible light, because we are seeing an object, is one form of electromagnetic radiation. But satellite used much more than the visible light. So, what is an electromagnetic radiation? It's a wave that travels without a medium, and across the spectrum it has a constant velocity of around 3 into 10 to the power of 8. exactly it is 2.997, but for all the theoretical and practical purposes, it is taken as 3 into 10 power 8. Let's look at some basic definitions of wave. What is on the right side of the figure? What is on the right side? What is shown? A wave is shown. Who is that responding? A wave. Okay. And there are some other definitions there. How do you know it is a wave? How do you know it is a wave? It has one up, one high magnitude, one low magnitude, and that pattern keeps on repeating at a certain interval, right? So then the definition of the wavelength goes. What's the definition of the wavelength? Distance between one particle in one wave and when it ends. It need not be on the top. It can be on the bottom also. It can be at the starting of the wave also. How much distance one particular wave occupies, that is wavelength. Okay. And how many such kind of waves are there in 1 second, that becomes the frequency. Okay. Now if I have a short wavelength, the frequency would be higher or lower, because in 1 second I have so many waves, right? So wavelength becomes short, so the frequency increases, because in one particular time, suppose from here to here, if I say 1 second, the high frequency waves are so many, but low frequency waves are only around recurring patterns. Yes, waves are recurring patterns. Yeah, high frequency will have shorter wavelength and low frequency will have longer wavelength. So when I say longer wavelength, how long it would be? Around 1 centimeter, 10 centimeters, 1 meter, 10 meters. How much it would be? Okay. Across the spectrum, it varies from crest and trough repeated. Yes. Okay. Across the spectrum, you have different wavelengths varying from 10 power minus 12 meters to somewhere around 10 power 3 meters. Okay. So 10 power 3 meters is somewhere around, how much it is? 10 power 3 meters. You can imagine this wavelength, how much they will go? Okay. Of these, only ultraviolet, visible, infrared, and microwave are used for satellites. Sensing whether it's oceans or land. Radio waves are used for communication mostly, and X-rays or gamma rays are never used because they are very high energy particles or high energy radiations. Ultraviolet also is used very rarely, and that too when you want to study ozone. Okay, most of the spectrum lies between infrared, visible, and microwave. This is what the satellites mostly use. Okay, now we will look at what are the elements, what processes goes on in the remote sensing. The first one is you require an energy source, and most of the times it is sun, but otherwise there are satellites which give their own electromagnetic radiation, or there are signal generators. Okay, then there is energy source, then it reaches the target area, it passes through the atmosphere, it reaches the target area, and then reflection goes at the target. So many things can happen. The target can absorb the radiation, it can scatter the radiation, or it can transmit down. So there are three processes which can happen at the target level. At the atmospheric level, there are some radiations which can pass through the atmosphere. Here also some absorption takes place, but I have written it twice. That is because uh, once when the radiation reaches the target, and then second time when the radiation reaches from the target to the satellite or the receiver. So it is twice. And then you have a receiver, satellite then gives the receiver, then computational, all the applications analysis is done here, and all the interpretation also done at the ground station. So what it means is, it's almost like, suppose I am throwing balls at a wall. After some time, I receive those balls. Okay. Then based on that, how much energy I am receiving, then I will estimate what kind of the target it was. So if I want to, I can't use all the, so this I mentioned, most of the times it is a passive remote sensing, because I don't want to waste my energy. So whenever there is sunlight, I use this, whatever the sun gives, from that only. And there is something like I want to measure something specific, and that time I'll use active remote sensing. That means I generate a signal, and then I receive it back. Then I compare how much of how much I sent, and how much I got back, and at what time. Okay. So I can't use all the spectrum for all the purposes. There is like something which have to do with the color. So light is sufficient for me. That visible light is sufficient. So if I want to look at vegetation, whether how much forest cover is there, that time the visible light is enough. And suppose I am looking at how warm it is there, whether it is sea surface temperature or air temperature, then I go for infrared. Okay. And ultraviolet is generally used to measure the water quality, but it is very rarely used for any purpose, because ultraviolet is not good for human health. So when they want to measure the ozone thickness, that time it is used, but most of the time it is visible light and infrared. And when it is very much cloudy area, and then it is uh, you want your waves to pass through the clouds, that time microwave region is used. Okay, depending on your application, what you want to measure, and you will use either visible or infrared or ultraviolet or microwave. Okay. And there are many types of satellites based on their orbit. Certain satellites have circular orbits, certain have elliptical orbits. Equatorial orbit, suppose I want to measure only the tropical ocean, then I have an equatorial orbit. Then the satellites will go only around the equator. And if I want to go from pole to pole, then I use a polar orbit. Or suppose I want to use an incline, because I want to concentrate on a particular region, that time I go for an inclined orbit. But based on the place or the altitude of the satellite, they are into three types. One is low earth orbit, medium earth orbit, and geostationary orbit. This is farthest. Okay, geostationary is Like when you are around 35,000 to 40,000 kilometers from the Earth, the speed of the satellite matches with the Earth rotation. So it appears as if they are stationary to each other. Suppose if you are looking at, their will relative velocity becomes zero. Suppose if two trains are going parallel to each other, okay, the two tracks are there and two trains are there, they are going parallel to each other, then you feel that other train is not moving, right? The same thing happens in the geostationary orbit. Okay, these are the some of the satellites which we generally use. These two are for sea level. Okay, and these sentinel satellites, they are from European Union. They give sea surface height, sea surface temperature, and chlorophyll. And Saral Altica is an Indian satellite. It gives sea level, but it's very high resolution. It gives in sometime less than a kilometer also. Okay, and then Aquamodis, it is an USA satellite. ASCAT, it gives winds. CWIPS, now it is not there. CWIPS is gone, that is dead. So that gives the chlorophyll concentration. Before ASCAT, it was QuickScat, which was giving sea surface winds. Okay, these are most of these satellites are currently under use. Okay, before going for all these things like so many satellites, so many orbits, why do we actually have to use the remote sensing? Now there is a picture in the left that is taken from, picture in the left is taken from, picture in the left, it's a camera, yes. Picture in the left is a camera and picture on the right is from drone. What is the difference? You get a better view, right? You can cover larger area. If you want to, suppose if I want to study how many trees are there in that park, okay, and I want to capture all of that, it gives an aerial view. Yes, it gives an aerial view. That means you are sensing a larger area at one go. Okay, now similar thing happens at the satellite level also. Suppose I want to measure sea level. Okay, what I can do, if I want to measure at one place, like almost like a camera, I'm taking a picture at one place, then what I'll do is I put a scale. Okay, and every time note down what is the water level, right? This is a picture of the tide gauge, how it measures the sea level. Okay, and this will give me the sea level at one place, right, or at one location. But if I want to look at a larger area, then I have to go for satellite, right? How do satellites measure the sea level? I know the satellite is placed at which altitude. Okay, that means from the base level, I don't want to go for the definitions of ellipsoid and gear, but this is a base level, or we can call it as a reference level. I know because I have placed satellite in the orbit. I know the distance between where my satellite is. Okay, then from here I send a signal, and then it comes back after say 2 seconds. Okay, now I know the velocity of this electromagnetic radiation which I have sent, and I also know when my echo reached. Based on that, I can calculate this distance, altimeter range, correct? I know the velocity, I know the time. Can I calculate the distance? Yes. It's almost like I am throwing a ball at the wall. Yes, velocity into time. But here time is twice, because once to go and once to come. So whatever distance you get, so that has to be halved, or you have to double the time, because once once the signal travels and then echo is reached. So in this way, the satellite measures the sea level. These are the later corrections, because you have to exactly determine the where the satellite is, and then you have to position the satellite. But this is a basic concept. I know the orbit or location of the satellite, and I send a signal, and then the time at which my echo is reached, based on that I get the distance. But it is not so simple, because so much atmospheric observation or attenuation happens in the signal, so a lot of signal processing also goes in. But this is a basic concept. Okay, this is a figure of a sea level. So imagine if I have to measure the sea level using the tide gauge every place. This much I can never cover, right? So this is a sea level for one of my works I have used. So I have generated a movie. I wanted to know over the year how sea level varies. Okay. So in January there is high happening. This is called as Lakshadweep high, then Lakshadweep low. Forget those terms, but at one go I will know over the year how the sea level is varying. Right? Okay. Now if I want to measure the temperature, this is called a bucket thermometer. So you'll use a thermometer into a bucket and then dip it in the ocean, and then you bring it up and then see what is the temperature. Generally thermometer is based on the expansion principle, right? How the temperature is measured, there is one metal which expands based on the temperature. Based on its expansion coefficient, you calculate what is the temperature. Okay, you always these parameters are you use a proxy to measure those parameters. You can't actually measure the temperature, but temperature uh, expands the metal based on how large or small that expansion is happening. The temperature is measured or calculated. Similarly, for the satellite, when the when the ocean is warm or cold, even in the air. So when the warm waters, they give out more radiation, and then cold waters, they give less radiation. Okay, and you can use either microwave radiation or infrared radiation for measuring the temperature. What actually it measures is the radiance, then radiance is converted into the temperature. But when you use a microwave radiation, it penetrates much deeper compared to infrared radiation. So what if you use an infrared radiation, that is called as skin temperature or skin SST. Sea surface temperature is skin, because only the very topmost layer. Whereas if you use a microwave radiation, because microwave can penetrate through water, you get a little deeper temperature of some layer of around 1 mm. Okay, this is a global scale. This is how the sea temperatures or sea level they are plotted. The what each color means is given on this scale. So you can see the equator is much more warmer, right? And poles are cooler. And this varies with time. Every day it varies. It varies seasonally, it varies monthly, it varies decadal. Okay, so one of these is interannual variation. Generally, this is a specific ocean. Generally, during a normal year, Western Pacific Ocean is warmer and winds uh, come from east to west. But what happens during an El Nino year is Western Pacific becomes cooler and Eastern Pacific becomes warmer. This is during an El Nino year. And the trade winds become very weaker and occasionally they reverse the direction. Okay. Whenever El Nino happens or whenever an El Nino occurs, most of the times it is a drought in India. So it is not like that we spend so much on satellites just like that. They are used to study climates, they are used to understand oceans, okay, they are used to study currents. Okay. One more measurement which we generally do is in chlorophyll. Just like plants are primary producers on land, plants are primary producers in ocean also. But there they are called as phytoplankton. Sorry. They are called as phytoplankton. So chlorophyll is generally measured because it's a color, visible light. So the sea water contains so much phytoplankton. They generally float with the water. So green light is reflected by the phytoplankton. So when the ocean appears greener, there is a high chlorophyll concentration. Okay. This is one of the projects which Pranav has done the last. You can see the other screen of mine. Yes.
No, we can't see the other screen.
You can't see the other screen. Now you can see the other screen.
Yes, we can see the screen now.
Yeah. So this is how the chlorophyll looks like. And one thing we can observe is very near to the coast, chlorophyll concentrations are very high. What could be the possible reasons for that? See here, very close to the coast. Let me go to the Indian Ocean. Where land is more. Yeah, I'll stop here. Yeah. Anyway, doesn't matter. This is, yeah. So very near to the coast, the chlorophyll concentrations are very high. What could be the possible reason for that? Why at the coast? Why do you think? What could be the possible reason for plantation? No, that is not touching. Yeah, chlorophyll is more because there are more plants. Yes, one is bathymetry is low. That means the phytoplankton has some touch towards the soil. So in the deeper ocean, soil is very deep. But otherwise, that more than that, because humans they send so much input into the ocean, most of the nutrients comes from human intervention. So that's why you feel that's why there is a high chlorophyll in very close to the coast. Now are you back to the presentation?
Yes, we can see the
Yes.
presentation now.
Okay. Now, after knowing this is the chlorophyll, this is the temperature, what I'll do with that? Okay, there are something called, okay. So as we have seen, SST or temperature are not same or uniform in the ocean, right? We have seen equators are warmer and poles are cooler. But even if you take a small region, this is of Kerala, you see there is a warm patch and there is a cold patch. Okay. Whenever there is a boundary like this, means when the cold water meets the warm water or warm water meets the cold water, along this boundary, chlorophyll is very high, and those are the regions where the possibility of finding fish is more. Okay, this is entire Arabian Sea. I have drawn the potential fishing zones or SST friends. Okay, so till now we have seen how do we use the satellite for data for our purpose, but in summary it gives large area, okay, and remote and sometimes inaccessible also, like polar regions we can't even go and measure, right? And repetitive coverage, every day you can get satellite data, and some day satellite data are 5 to 6 times in a day. And if you are using some cameras or only human vision, what you can sense is only the visible range, but satellites go much beyond human vision. Okay, and using the data you can monitor oceans, you can monitor forest, you can monitor ice caps, floods, cyclones, oil spills, etc. And apart from that, there are large scale studies. Cyclones and oil spills are short term, like they are there for 4 days, 1 week, 10 days. But global studies, climate change and ocean currents, they are there for almost so many years, so many multiple years, like decadal years. Now, this is the most, if you are participating in NASA, try to understand this data structure. I will go little slowly, but this data structure is very important. Suppose, okay. So when the satellite measures the data, it takes suppose, say, let's look at it as a camera only. It has taken the photograph. So this much region it covers. But when the satellite travels like this, you will get a path. This is called a swath of the satellite. Okay. In this swath, you will divide the grids. So grid 1, grid 2, grid 3, grid 4, like that. And suppose I have some data here. I have some Y, mostly to the longitudes, but this is just a random number I have taken. And X in the satellite, it is longitude. And I have some data, say temperature. Suppose I have measured the data for 4 grids. Okay. X grid is 10, 20, 30, 40. And the Y grid is 110, 120, 130, 140. Now, if I have to represent the data like this, on the day 1, my Y value, my X value, and the data. So for just 3 days and 4 points, this has become this much big table, right? And suppose if I want to save the satellite data of this entire swath, so many longitudes, so many latitudes, and it becomes nearly impossible to get or store the data in the ASCII format or table format. Okay, so what is used is netcdf, common data format, which most of the 99% of the satellites, they give the data in netcdf. So this is the swath of my satellite, and I have converted that into grids: first grid, second grid, third grid. The same data which was in table will be now in this format. Okay. So I have X values 4. I have Y values 4. So what are those? I will just list it once. Okay, 10, 20, 30, 40. In that ASCII format, which we have seen earlier, that 10, 20, 30, 40 was repeating so many times, right? Whenever the data is changing, you have so many times. For every one latitude, you have 4 longitudes. Okay, for every day, you have 4 latitudes and 4 longitudes. So it is 16 longitudes. So here in the NetCDF format, I don't put all those. So many times I don't repeat X and Y and then time. Only once I give the array. This is X, 10, 20, 30 and 40. And this is my Y, 110, 120, 130, 140. And time, 31, 59 and 90. For the timing, I have taken as some example. And the temperature is 111, 211, 311. If you are used to programming, you will understand why I have put the temperature as 111, 211, 311. But temperatures are not that way. But how many of you used to programming? Yes. So you understand this? What is 111, 211? Yes. So X is generally longitude is a fast running variable and Y is second fast running variable and time is slowest running variable. See here. First X varies so many times. Then after X has varied so many times, then your Y varies. Then after Y varying so many times, your day changes. Means any time, whether if it is daily, if it is hourly. Okay. So now I don't say what is my X, what is my Y, what is my time. So I will just give the data points like this 111, 112, 130. So whatever is my first value, it corresponds to X is equal to 1, Y is equal to 1, and first value of time. Okay. Then whatever is my second value, it is I is equal to 2, J is equal to 1 and my Z or T is equal to 1. So it is like I save all these as slices. But I don't, like in ASCII data, I don't determine what is X, what is Y and what is time in this. Based on its position, it is understood that it belongs to X is first value, Y first value and time first value. Now if I look at this, because it is second in the time, so I know it is second time position. So it corresponding, suppose I am measuring the satellite data from 1st January to the 2nd January. Then I will, based on its position itself, I will know that it is on the 2nd January data belonging to 3rd latitude and 3rd longitude. Okay. Which otherwise would have taken around 30-40 GB for one data sets. If you are putting in ASCII, NetCDF will take hardly 60 to 70 MB or somewhere around 200 MB, much less than a GB also. So try to understand this format. If you are participating in the NASA, you are bound to use the NetCDF files. Yeah. It need not be a 3D matrix, it can be 4 also. Suppose I am looking at salinity or temperature. There is a layer, right? At depth, the surface, at the depth -10, depth -20. So that time depth will become the third running variable and time will become the fourth running variable. Time is always slowest running variable, and then longitude is always fast running. It is, yes, if you are used to matrices, it is a 3D matrix. If depth is not there, like SST, it's only surface, right? I have only X, Y, and then data. Some satellites are capturing real data, but you need to ask somebody. INCOIS in India, if you are asking, INCOIS in Hyderabad is the holder of the data. So once when we are running of these SST friends, like our ship is in the ocean, and then we have to draw these lines and guide the ship where to go. That time we wanted the real time data. So that time we used to ask inquiries, please give us the data, and they used to send. Then that was 6 times in a day that data was. But to capture one frame, it takes around half an hour to 40 minutes. It is not like 1 second. The satellite path goes for around the entire swath to cover, our entire basin to cover. It takes around 20 to 30 minutes. Yes, I will show you the format again. If you can, yeah, I will show you in my this one. This is more better. Okay. Yeah, this is our ADCP data. This is netcdf format. Generally it comes in the .nc format. Then I will ask it to show data. Then it will show me it has zonal velocity, meridional velocity, vertical velocity, and error velocity, and echo intensity. So it doesn't, because ADCP is at one location, I don't have longitudes, I don't have latitudes. What I have is depth and the time. Okay. Then if I want to know what the data is, then I will know it is from 552 meters to somewhere around 984 meters. And the data starts from 9th November 2016 to 9th November 2017. And if I want to see what is there in that, I'll just plot it. Okay, this is how the currents in the ocean vary.
Aparna, I have one question.
Yes.
So this you mentioned the data is maintained by one company in Hyderabad. So if you
INCOIS.
want,
It's
yeah,
a national center for information and ocean
okay,
sciences. Yeah.
okay. So in case like someone like public need to consume this data, they provide API or they provide dump of the data.
They provide netcdf files.
Okay, okay.
They
Okay.
provide netcdf files. So
So
if we
we
want to handle satellite data, it is 99% netcdf. Unless until you mention that I want ASCII data, then only they will give. But handling ASCII data is difficult.
okay.
So
So
there are many other sources for data. I have just shared a NASA site also. So there are
okay,
many public sources of data. Almost all countries which send their satellites to also share their data in various formats. One of the formats is netcdf format. I've just shared the link of NASA data source. So you can just check there. They're available in various time series, past data, present data. So it's a very exhaustive set of data. You can filter them as per your requirement and download the data.
Yes.
got it. So
Uh,
just for my curiosity, in NIO, when you get this data, how do you process it? Like, are you using any cloud technologies or just your own framework? Just for my curiosity.
How to handle net CDF data, you're saying?
Like, you must be getting large volume of data, right?
Yes,
Uh,
yes, yes.
so, what technology you
That's why
use?
we can't use the ASCII data because it's very huge. The CDF
Okay.
data converts the entire. See, this is almost 1 year data for every 15 minutes. Like you have 8,074 points in the time and then 55. So if you take 55 into 8754 into it's because it's a real, it is into 8, those many bytes you require.
So I think the question was the data that you get. So you download whatever you require, right? You don't get by mail any data. So you go to a
Depends on
particular
the
site.
usage.
Yes.
See, most of the American satellites they give data free, even European. But Indian satellites you have to ask mostly from incoys, either from SAC. And depending on your necessity, either they sell you the data or they give you for free. If it is for
No,
academic purpose, they give for free. Then it depends on them whether that NASA for the you have to click for the NASA the website the recently you have to click the time you want and the region you want and then it will download. You can simply download from into your laptop or the system. But there
the
is
question was, I think what Omkar was asking you is, how do you process the data? So do you have a particular framework? Do you use some kind of open source tools? How do you process such large volumes of data?
that's what I show you. Not mostly we use the Spirit. That's why I use this software. I was showing you how the data used to plot or process it. Okay, but it is not compulsory. You have to use this. So people use MATLAB. People use Python. There is Surfer. You can use many softwares are there in that way.
Okay, got it. So, Saish, for this hackathon, right? Means,
Mhm.
do you have any thought on what kind of data we plan to use, like NASA or Indian data or any other data?
So no, it depends. See, it is nothing to do about data. So there will be theme statements released by NASA hackathon on 15th of August. Based on the
Okay.
theme, the participants will select a particular theme to work upon. For example, let us assume that you want to work upon, for example, this is last year's problem what Aparna is showing right now. This
Okay.
problem was about using PACE data. So PACE is one of the satellite missions of NASA. So they share data on chlorophyll and many other data sources. So this
Hmm.
project aimed to create some kind of a visualization tool of the phytoplankton data across the world. So that was the
Okay.
problem statement. So the competitor, the participant, downloaded the data sources for a period of 1 year and plotted it to a particular visualization, which is 3D. So the creation of this visualization was the submission to the hackathon. In this visualization, you have this globe, right? In this globe, you have this filter about months, January, February. You select a particular month. In the left, you can see a particular data type, and then you can see what is the phytoplankton. So this was the problem statement that was submitted to NASA, in which only 1 year's data was downloaded from the NASA website. So whatever you download will depend on the problem statement.
Okay. Got it. Understood. Thanks.
But what is required is that there is something called as data source, that this data source exists in multiple formats. One format is NetCDF, which you have learned today. There are many more formats. So we have to be aware that there is something called as satellite, there's something called as remote sensing, which creates all these data sources. And these data sources can be used to solve larger problems, which we cannot solve from the earth, right? For example, if you are having a drone, your swath, matlab your point of area will be very small. But if you're using a satellite, you get an entire globe's perspective, a picture of the entire globe for the past so many years. For example, you want to know, for example, this debate is happening in Goa, right? That the forest cover is decreasing. So how do
Hmm.
you arrive at this data point saying that forest cover in Goa is decreasing? So there will
Right.
be a data source on one of the satellites which has a vegetative index across years. So you
Hmm.
plot this vegetative index across, say, 10 years, and then you will arrive at extrapolation that the percentage forest, which was 35%, has now come down to 24% or whatever it is.
Got it. Got it.
There was
Understood.
approximately reduction of 22% forest cover in Goa in the past 2 years.
Oh, wow. So this is good to know.
Another
Yeah.
example is you want to know encroachments in the coastal area. There is this debate about CRZ, right? That there are encroachment in the coastal. How do you do that? That's very easy by satellite data. The data is available on NASA website, very open, and you can solve that problem. Only what you need to know is, okay, to arrive at encroachment on coastal security zone, you need to know which area there is this encroachment, what kind of light parameters. Matlab, you'll have this kind of data sources also, and then you need to do some kind of extrapolation. All that is possible through satellite data.
Yeah. Thanks, Sai. Thanks, Aparna.
Question. Does the X and Y always vary linearly? Like, is there always a linear progression?
That depends on the which level of the data you are using. So I'll talk about the wind. There is level 1, level 2, and level 3 and level 4 data available for the wind. So level 1 is unfiltered along the swath. Okay, and then it has variable lat longs, like latitude can be 15.4111, and then longitude can be 73.228, that exact position. Okay, whereas in the level 2, those are rounded off to a small grid, but still in the path of the swath. Once you come to the level 4 data, it is completely gridded, like entire ocean is taken as a map. So level 1, level 2, you have a swath data.
Okay, got it.
It's all, but nowadays, most of that, unless until you ask for the level 1 and you want to do some processing based on you want to arrive from level 1 to level 2, but otherwise most of the readily available products are gridded. Means you will get processed data at regular intervals, like 10 north, 11 north, 12 north, something like that, or 10, 10.5, 11, 11.5 equal.
So I've just shared one file which shows that NASA's Earth data is available in various levels, as been just described by the expert just now. You can check that page. It describes various levels. Incidentally, NASA processes all this data into various levels. So it becomes very easy for users like us who are not experts in handling data. So you can get a fairly amount of processed data. So in processing, there's a lot of algorithms which are involved. So they do a lot of processing. So I think that is one major difference between what NASA does and what other countries do. NASA puts in a lot of effort to process the data and share it with the users.
No, even
Unlike,
EU and even if you want Indian satellites also, they give gridded data.
okay,
But
great.
yeah, but now I have heard recently that even US has stopped giving the data for free. So they also want to sell the data. This is last week, last 10 days development. When they will implement exactly that, we don't know, but that is going on.
Anyways,
So
the users of NASA hackathon will get access to data sources. That won't be a challenge for the participants of the hackathon.
no, this is for general research purpose. I'm
Yeah.
saying.
Okay. So, Saish, I have one question. Like in terms of like for this hackathon, right? Will the volume of data will be very large, or it will be which we can do on a local laptop, or we'll have to use something like cloud technologies or infrastructure where we need to process this data?
So this is not the intention, right? The intention of this hackathon is not to process large volumes of data. It is to show a
Okay.
proof of concept of the problem statement that has been solved.
Got
So
it.
for
Got it.
example, just now what we showed you was 1 year data, right? About the phytoplankton being visualized on Earth. It's just 1 year. So it
Okay.
is the proof of concept that you're showing that you've understood the problem, that satellite
Okay.
data exists to solve a practical problem of potential fishery zone. So it is not about crunching data or processing it in large format. That is not the intention of the hackathon. That is why I said, please refer to the earlier winners. You'll get a fair idea about what kind of processing happens.
Got it. Got it.
This project was done in normal laptop.
Okay. Understood. Yeah, sorry, I missed the first session. I'll go through the recording. Yeah, but yeah, I got the idea, Saish.
Now, if the presentation is over, we can ask question. We can take questions, Dr. Aparna.
Yes, yes.
Great.
Already question hour is going on, right?
No. Any other members of the audience are please free to open to ask questions. Please type in your questions in the chat window.
You can visualize NetCDF data using Python, Java, MATLAB, Octave, but I personally use Ferret.
Sorry, what is the last word that you have used?
Ferret, ferret.
Ferret. Okay.
Actually, it means a cat.
Okay.
Surfer is also there.
We'll be having more sessions on how we can use these tools. We have one session on Wednesday as well. We'll keep on learning about these tools one by one.
Yeah. Can we set up like a Python notebook which shows one sample of?
We lost you, Yash. We can't hear you. Can you be clear?
Can you hear me?
No, we can't hear you yet.
Hello.
Yes, please.
Audible?
No, we can't hear you yet.
Yeah, I think what he was asking was instead of having a full-fledged Python code, can you test it on maybe a Python notebook or Jupyter or something like that? Yes. So what you can do is you can do a test, and for example, Python has modules to access different types of formats. So NetCDF you can use one module, and
Xarray
so
is the module.
yeah, and then you can use also inbuilt MATLAB modules functions to access the data. So you need not expand entire NetCDF, but you can just pick up whatever is required from the NetCDF file. So as Saish was mentioning, there are different formats. So one common format for mostly oceanography, environment related is NetCDF. But if you go for let's say astronomy, there is a different format, FITS format. So it's like just JPEG, PNG, which has different most different information what will be used. So in fact, even without downloading the data, you can give the link, you can extract using either Jupyter notebook, those kind of things, and then if you think that is useful, then you can download the entire data and then use it on local machine. So most of the things I think you should be able to use and process on local machines, laptop or desktops, most of the things. And I think the intention of NASA's Space App Challenge is not to really process a lot of data, but use that data for developing new applications, developing new storylines, and even writing stories and doing some discoveries where you will require some use of data. But I think their intention is to really so that people all over the world develop some technology so that use of data will be easier for discovery. So I think that is their intention. And then again, it's a good use of NASA's investment into all the technology, science, data.
Yeah, any other questions from the audience, please type in. I have already shared one small quiz on the Google Classroom about today's session. It will just refresh your knowledge about today's session. Please, attendees, please respond to that quiz. We will share the recording for this session. Welcome to Dr. Trivedi. I just missed out that you are attending the sessions. Welcome to you.
Yeah, I joined a little bit late. We had another program today. So what might be also good is these sessions are really good, giving participants some idea about science and then data, what kind of data is being used. also maybe then we can have some discussion on, so it should be some sort of homework for all our participants, what previous winners were, what kind of projects were there, that we can spend, at least few minutes or maybe even a dedicated session just to see who were the winners, what kind of projects were done in the previous year. So we get what science was done. So what were their ideas, and then based on those ideas we can filter out some new things, and then maybe what kind of data. So that way we will be able to little bit focus, and then tone down some narrow down some areas.
Yeah, I think that's a brilliant idea. Let's look at that one expert who takes up that session. Anyway, Wednesday we have one session on data collection.
Yeah.
So
What I was saying is let
yeah.
all participants go through the winners last year before, and see what kind of projects. And so it's like a homework for everybody.
Yeah.
And then maybe one dedicated session just to go through and then discuss.
Yes, that would be brilliant. Let us do that. Yes.
So I will give one session on astronomy data. So I will finalize the date. So once we go through the previous this one winners and projects, then one day I will have a session on astronomy data. So that can be done.
Perfect. So I've just shared the list of winners for somebody who's asking. I think Google is a better way to ask. Google has everything. You can ask it everything and you'll get the answers. I would like to share one important resource that you can continue learning about remote sensing. Let me share that with you. I just share my screen so that you have this. Let me just share. It is this RSET. So if you see my screen, there is this RSET, ARSET. So they have this self-paced training courses on remote sensing. So those of you who are interested in learning more about remote sensing can go through this fundamentals of remote sensing. Hope you can see my screen.
Yes.
Yeah. So if you click this so there is a login. You need to log in. It's a completely free thing. You can simply log in, and if you go through this, it's a very self-paced course. Whatever you were exposed today to this session, you can learn more in detail. You can earn a certificate as well. I will share this site link in the chat. So this is an extra thing. If anybody was interested in pursuing remote sensing in depth, can check this course. So it mentions what is remote sensing, objectives of remote sensing. It's a very small course. How does remote sensing work? How can I use remote sensing data? And practice with worldview. This worldview is something very interesting. Worldview gives you the entire different data sets on a global view, on almost near live. I can share that link as well. Just a minute. Let me stop sharing my screen. The course, I've shared the course, link to the course on the chat. Any other questions, please feel free to ask. Let me share my screen again now. Yeah, as you can see my screen, this is the NASA worldview. It has different data sets. For example, this is, I think, for fires. You can check different, wait just a minute, worldview satellite. Yeah. So you can change the base layers, add data sources. This is an amazing resource wherein you can enter. For example, I want to see particularly about Goa. It will say Goa, India. It will zoom directly to Goa. So this is a particular data set that you are viewing. So this worldview, you can explore different data sets which NASA provides. I will share this link for your information.
Saish, if you go unzoom it, no, little bit, just unzoom it.
Yeah, just a minute.
Yeah, this
Yeah.
is in between the two swaths. Actually, it was not covered by the satellite. So
You mean the black line, the black
yeah,
band, right? Yes.
one swath is from end of this black line to the start of this black line. So next swath is not here. So that gap. And if you zoom further, you can see these black lines more. Zoom out. Yeah. See. So this is the swath of that satellite. Oh, I don't have the cursor. Yeah, but anyway. You can make out, right? So nice it is actually. Yeah.
So in this area, there will be no data, right? So there will be a data gap
If
wherever
you
this.
use level 2 data or level 1, but if you use level 3 or level 4, they will fill in the data using either yesterday's data or it's some kind of interpolation, whether in time or space. Or sometimes they leave it, if it is unfillable, they leave it as a gap, but most of the times you get a graded data.
So you can see at the bottom, there is this time series also. You can change the time series to know a particular data point. That's why I said, if you want to know vegetative index, the forest cover for Goa, you can do it right here in the world view. Fantastic. Okay, let me stop share. I will share this link to world view viewer. Yeah. Here it is. I will share all the links in the WhatsApp group also. Okay, great. Let me end this session because we have crossed the limit of 1 hour. I would like to start by thanking our expert, Dr. Aparna, for conducting an amazing session. Also for the organizers from Director of Higher Education, Dr. Vittal Tilvi, for being such a gracious host in making this happen in Goa. To all the participants for being present,